Development Program and Data Science Tools, organized by the Department of Artificial Intelligence and Data Science of SR Rameshwari Engineering College. Our today's session is on Skikit-learn, Matplotlib, and Plotly. It is an honor for me to introduce and welcome the keynote speaker of the day to our session, Dr. N. Subbaya. Is currently working as Principal Data Science Consultant at Sixth Consultancy and is Dean at Data Science Practice and Chief Data Science Mentor at Academic Mentoring. Academic mentoring activities mainly on Bayesian techniques for actual application. He has published over 25 research articles, authored a book on random processes, and developed 4R packages. We are happy to have you with us today, sir. The session is yours.
Uh, Thank you. Whether I am audible?
Yes, sir.
Okay. Okay. So, first of all, I would like to thank everybody, including the organizers, SR Rameshwari Engineering College, as well as the participants who can extend their time and their efforts to connect with this program, as well this particular session on the three major tools are specified by the organizers, in fact. So it is a very interesting to give you an overview about the three topics, whatever we planned today. In fact, there could be many overlapping between the requirements as such between the topics, because when we consider Python for data science, for example, then we can relate it from starting basic Python tools to the advanced TensorFlow or whatever may be the case. Depends on the requirement. So these three tools, specifically Plotly, Matplotlib, which are two tools for graphical analysis, I mean graphical outputs. Whereas Scikit-learn is a particular tool. It may not be exhaustive or it may not be so unique. In the sense, we have the competitor for that also, like Matplotlib and Plotly. Both are more or less in a similar objective, but the utility is different and the purpose is different. When you want to use Matplotlib and when we can enhance it with Plotly, that is what we are going to discuss from this particular session. As far as Scikit-learn is concerned, it is a different tool altogether for a particular application of data science practices or machine learning practices, whatever may be. These three terms, data science, machine learning, artificial intelligence, they are all very much buzzword today, are widely used today for any applications or any academic activities. So more or less it becomes a very, very inevitable component for any department for that matter, stating from language, anthropology or psychology or engineering, computer science, so everywhere. So application is multifolded, obviously. So it doesn't sit completely on a computer science department, but the core of this data engineering and data science application of AI tool, development of AI tool is completely lying on the hands of engineers and the team of data science together. The word science and engineering is overlapping in this particular area. That is what my observation. I'm endorsing my point. Okay. So with that aspect, what is the purpose of various packages or various libraries in Python, like NumPy, SkyPy, or Pandas, etc.? Each has a different goal as far as data science is concerned. I'm not talking about the whole length and breadth of Python as such, as a programming language. I limit myself to this data science application and that too in Scikit. So first I'm going to talk about this in a very short time frame so that we can browse through the code point of view in the subsequent 2 minutes. Okay, because I believe, and sorry if you can interrupt at any point of time if it is too basic or most of you are able to understand, I mean, have this exposure already. So I assume a broader group of this audience, not by the number or size. I just imagine that or I take it granted that it could be a combination of different faculty members as well students and other practitioners of data science. So with that, I just connect the point. I don't say I'm going to explain everything. No, it is just a connection between what you have, or if you don't have that exposure, it gives an overview of where we likely to do. So basically this data science job or data science task as such, starting from understanding the data components in the sense cleaning and how the quality of the data is available, then we try to analyze towards our objective. So obviously, needless to say, we start from the objective and we focus towards that objective. In that, the essential component is cleaning the data. So that I'm not going to focus. The second part is analysis. When it talks about analysis, it comes with two different and major thing. One is on the descriptive part and another one is on the inferential or model building part. So there is a slight difference in the terminology, which you could feel, from other materials or other providers, whatever may be the way. Because today the materials are available widely and in a different ways. Say, for example, I may prefer to say a variable. I may prefer to say a column in a data frame. You imagine a spreadsheet kind of thing where we have rows and columns, where we have cases and variables. So the name can be columns or features, right? So the jargons are different, the terminologies are different, but all of us are leading to the same way. So broadly speaking, the descriptive is quite important because we try to describe the data what we have. The first step which I miss here or I skip here is deliberate, because we don't do today in this session with this topic, we don't do anything on data engineering. That means looking out how the quality of the data is going to be. So that we don't do it, of course. Anyway, this ELT or ETL and other aspect come into the picture of doing all those things, and how we try to create data lakes or very big database while we do all those kind of essential part. Okay, so here I'm focusing on the second goal. And third is, of course, to interpret or to explain our results. And fourth is, of course, to make it as a product.
Excuse me, sir.
Yes.
Sir, are you changing the slides, sir?
No, I don't. I yet to.
Oh,
So
okay, thank
I'm
you.
connecting this second word, analytics, why we are doing it. And then we are going for the models. That is the third aspect. So the models as such will be in a different way. There are a lot of tools, and scikit-learn is actually um, a compendium or collection of these models. That is what we try to make it a point. So that is the major goal in most of the data analytics projects, or even if it is a research. How we fit a model and then predict using the model and go ahead with that. There are a lot of restriction assumptions before we build the model, and there are some metrics to understand the performance of the model. These are all before and after hand of our analysis. So this part is majorly covered with these three tools. So let me summarize. Matplotlib and Plotly are for the first goal of describing the data, and second is scikit-learn is fundamentally covering. I say already that it is not so exhaustive, but it has a vast collection of model building tools. So descriptive statistics will give you a hindsight of the picture, what happened, what is your data all about. So naturally we need to do that. Then is diagnostics, which normally we don't do because it comes with practical applications. I don't know how many of you are typically practicing data science projects. So where in which we have to use diagnostic way and why it happens. So mostly connected with the subject matter experts, or we have the domain people, business values together. Then predictive part, that's what I say model. Mostly this word model connects mostly with the predictive model, but predictive models are not the only agenda or the aim of data science. Not so, but it is the major part today. Then prescriptive, that is also a part to optimize our area. So collectively, We are going to report what we have through this descriptive analytics. For that, one such tool, there are plenty many tools are available, and you have exposed already to R and R Shiny, where you have the static reports to interactive reports. Here also the same. Only thing is language is different. Of course, Plotly is available in R also. There is no doubt in it. And Shiny app can be developed with Plotly also. No problem. So the difference is what is the way you are trying to enhance. What is the way you are going to produce the plot is more concerned here. So Matplotlib and Plotly are distinct in that sense, but they are all serving for the common purpose. Are you going to give a dynamic reporting, or are you planning to give a static reporting while you mail it or present it in a static medium, maybe in a printed medium or in a PPT, whatever, maybe the way, right? So diagnostics, you try to correct. Okay, I try to correct even the analysis plan, or I try to get the inputs from the domain experts or the business people to do analysis more and more better. Then the third one, yes, of course, the name itself is saying, but it has a internal component also. So it tries to help how to do the prediction. Then the last one, recommendations. So today we are seeing a lot of recommendations when you are using an e-commerce website or a bus ticketing, anywhere whatever you try to do for your personal or any thing which related with data and internet oriented business, then you'll get a lot of recommendations. So people like this, people won't do this, etc. So that kind of foresight may be possible, and that foresight which is given as an output of prediction model can be furthermore optimized to the group. So I'm able to predict, okay, this will have the sales value, but to whom I have to focus? For example, for a sales campaign, to whom I have to focus? Which group is more likely to do? These kind of questions are not typically answered by predictive models, even though it answers, yes, we can. But recommendation together, it goes with prescriptive analytics. These are all the four major blocks of modeling aspect. This is, except I could say the right part, diagnostics and prescriptive, the predictive analytics is largely covered in the Skykit learning tool. Okay, of course, as I told you, there are other packages also, stat models, etc. in Python. Therefore, this is not the only thing. That kind of uniqueness we cannot bring out, but of course, it is a well trained, well tested, quite long community is there, and supporting blogs are always presented, and there are a lot of exhaustive groups are working on, because in open source, needless to say, you people, that it is completely built by individuals, so of academia, or if it may be a research group, or it can be a sponsored group, it can be an university people. So we have to be very much aware that who is backing up these kind of free tools. Okay, for example, Matplotlib or Skykitland. Skykitland is tremendously supported by that group and very active. In fact, you can have Twitter group, you can have their blogs, etc. So I leave it to you to browse their web page to get the help page and other stuffs, so that it is one among the active libraries as far as Python is concerned for data science practices. In that way, the choice of Scikit-learn is justified from my point, as well as we can mutually say that point. Okay. Yeah, so that is the purpose. So that is what the first 15 minutes I would like to spend. Why do we need these tools, right? Then the third one, that Plotly is to develop as a free open source. No doubt in it. We can learn very much as an open source, but it is having the enterprise edition also to go for production level utility, and then the further interactive app, what you have done in R, what you call it as Shiny. Here there is a good tool called Dash, and there are many tools to produce a web app or mobile app as a dashboard, and so on and so forth. So the extension from Plotly is again a long roadmap. You can, if you are willing to do, yes, you can go ahead with that. But as I told you, this predictive analytics have two components. One is the inference specific model, where we don't key or we don't mainly focus on prediction. We may have to use on getting that inference. Inference and prediction has I don't say subtle, it has a visible difference between these two utility. Okay. Um, People may be very catchy about the word predictive analytics. That is how most of the blogs, even Scikit-learn own blog or the GitHub support for that blog or that package are highly motivated by that kind of what you call it as predictive analytics alone. But the data science is not always to predict. That also we have to understand. Sometime in some environment like medical data, or we need to understand what are the factors which could affect, so that we may think about tools like feature selection or variable of importance in an in a unsupervised learning and so on, so on so forth. But beyond that, sometime we may have to understand the causal relationship, strength of causal relationship also, why it happens, in what amount it happens. These kind of aspects are covered in something called a specific inference specific model, where we try to interpret them. But in predictive alone model, it may not be possible. When we say a black box model, for example, a random forest, or even a linear prediction model, um, we cannot, understand the typical relation between the variable, what you call it as predictors, to the response variable. Okay, so in more simple term, explanatory variable and response variable. So the aim may not be that. Therefore, there is a difference between the word inference and predictive, but both are more or less covered in the same bunch in most of the applications, whatever the language. Okay, so even in Scikit-learn, it is done. Therefore, it is our responsibility, our effort to find out what is our objective, and based on that, we have to find out the correct tool to apply. This is an essential ingredient before we embark any data science project. No doubt in it. Whether you use Scikit-learn or other tool for building your model, that is not the question. Therefore, I don't want to give a picture that Scikit-learn is a God-given tool that can solve any problem, any type of problem. There are certain limitations in using, especially on the left hand side, inference specific model, where few things have to be enumerated, few things have to be coded. So therefore, if you are a regular Python user and you are comfortable with NumPy or Pandas, so that you can handle the database queries quite comfortably, yes, you need that prerequisite. So I am not going into that depth. I will give only the hint that before you plan to do on Scikit-learn, make sure that you are clear on your objective as far as modeling is concerned. Whatever the way, whether you call it as structured model or unstructured, unsupervised model, or whatever the way, you have structured data or unstructured data, you are going to only predict, or you are going to use the inference model also. So it depends on how best you are trying to build a model based on a criteria called flexibility. Okay, and the objective is the leader, that that leads the way your analysis plan should be. So without an objective, there is no part of doing any analysis. Unless we know what we need to do with the given data set, there is no part in it. As far as algorithms are concerned, methods are concerned, flexibility plays a role in terms of optimizing our time and effort, space, etc. These are all the important prerequisites before you embark into a tool called Scikit-learn to build your model. Otherwise, there is no straightforward code sharing to you. It is available everywhere. Any blog writing by few selected people, not all, of course. I am not that much optimistic in reading or propagating reading too many blogs, because the selective blogs are good. Some of them are routinely writing or copycat things. Some of them are some of them are misleading people, misleading the readers. So you have to be careful in choosing the right material to understand. So in that sense, I am giving a intro that unless we are prepared to analyze a data that this is going to do this job, we are not ready to do any kind of tool. One such is Scikit-learn. Okay, I assume you people are quite firm. Yes, The flexibility comes in terms of functional form. In what way you are going to, these are all various models which is having a low flexibility to high flexibility, at the cost of you are losing interpretations. So interpretation sometime a key factor, sometime it may not be. For typical prediction model, nobody cares about interpretation. Therefore, we need to go for very high flexible model so that interpretation we never care about. One such thing could be support vector machines or something on that area, okay, neural network and so on and so forth. So this is borrowed from the textbooks, which is one of the nice one, Introduction to Statistical Learning, though it says, but it covers these kind of topics. So yeah, that is what I told. Unless you have the objective, it is very difficult. Okay, so I go quickly into this kind of aspect, what we call it as typical model, where perfect linearity is explained. Linearity means straight line relationship or a nonlinear relationship where you have some equations was shown to you. Don't worry about that. I am not going to deal all these things today, but these are all just a connection, making connection between you and me, that this is the thing that Scikit can bring out. Okay, so this modeling, what you try to do is the objective. Objective means you need to do whether I'm looking for linear mapping or non-linear mapping, and then decide which is best for your thing, whatever may be the analysis, whether it is descriptive or diagnostics or predictive. So because there is no only one model to explain everything, there is no model. So they say all models are wrong. Some of them are useful. So what do you mean by all models? We have to work out very, very optimistically to get the right model to be done. So it is very, very challenging and interesting, of course. So there are a lot of performance measures I told. These are all few things I just spot out. And the difference between inference and prediction. So we are trying to frame the relationship between a set of predictors or explanatory variable to a response variable. If your model willingness is to understand how it is related explicitly, like the fourth line in my mathematical equation, then it is an inference oriented model. I don't bother about how it is. Just I'm trying to predict my f. Just if I try to find my f, I don't bother about the individual weights, then I don't care to infer. That means I'm going only a prediction model. So this is a larger difference in a very, very quicker way, I can say, very broad way of understanding the difference between inference focused model or prediction only model. I am not going to give any mathematical relation. That's why they are sometimes called a black box model. We don't know what is going on. It may predict, yes, the particular patient may have something, or the particular product can be chosen by a visitor of your e-page, a web page, whatever the way. So it is only a prediction, not on anything else. So the anything else comes under the part of inference. So where we need the weights play an important role in all these cases. And then we have to have whether it is the linear weights we are looking for, or non-linear relation we are trying to look for. Linear I told already. So I'm going to take a simple example before I run the code. This is the example data set. One is selected, of course, it is all available freely. We have birth weight data. So it is giving the relation. This is one of the descriptive relation between the gestation week, one of the variables, and the birth weight of the baby during the delivery. Of course, when we have a medical relation exists. This is what conceptually, that means subject oriented people can say, is it a plausible relation, a reasonable relation which you want to study. Therefore, such things can be plotted in a scatter plot because both variables are numeric. Therefore, one more point we need to understand is basically data types. Broadly, numeric, categorical, binary, and polytomous are more number of classes. Then count data. I don't treat count data specifically today because most oftenly count data can be treated as numeric, no problem. Numeric is float type. Okay, so it can be used for measuring quantities, height, weight, time, and so on. Of course, height can be grouped even taller, shorter, and so on. Therefore, it doesn't mean that always height is a numeric, but mostly we measure by inches or centimeter or even meter, whatever the unit you are preferring. Similarly, weight, it can be kilogram, pounds, or it can be low weight, underweight, obese, etc. So it can be categorized also. Therefore, none of the theory can forward that these variables are always numeric or these are all always grouped. Numeric values can easily be converted into groups. So needless to say, they can be overlapped. Okay, so it depends on how you treat them. Should we treat it as a numeric as such, or can we make it as a group? Invariably, the vice versa operation is not possible. Once you measure it with categorical variable, going back to the original number may not be possible unless the complete data is given to you. So that danger or that limitation lies on this kind of data transformations. So you have to be careful and judicious in understanding what type of data you are handling. So naturally, the larger three types of data, numeric, which is coming under the measurable classification, and categorical or factor. So that is usually for labeling like gender, male, female, or season, sunny, rainy, and so on, or something like that, which can be factored. Okay. So they are either two levels, therefore it is binary, or more than two, so that it is polycotomous or multi-level. Okay. So dichotomous means two, more than two means polycotomous. That's the word. And then we have count. I don't take much on here because it is a very special way of handling modeling and so on. Therefore, I don't take. We can consider time being that count variables are also in terms of numeric, because there are also numbers which have numeric sense. Two people, three, four, number of hours taken to travel from point A to point B, 3 hours, 4 hours, 5 hours, 7 hours, something like that. So it is whole number, but it has numerical sense. Sometimes categorical variables may be labeled as numbers 0, 1, 0 for male, 1 for female, 0 for success, 1 for failure, and so on and so forth. But they don't have numerical sense, even though they are labeled as labeled numerically, but they don't have any numerical sense. This is another bunch of quick information you have to understand before you embark into any these four objectives of modeling, because it's essential. Even to draw a descriptive summary, we need to know what is my data, whether it is numeric. Okay, I can do some set of like mean, median, maximum, minimum, and so on. If it is count, I cannot give a mean. I have to give, sorry, if it is a categorical, I cannot give a mean value. I have to give only the percentages, only the counts. So it all depends on the second input, namely data types. Data type means nothing to do with the computer science, typical programming language. The understanding is similar, but we use it for a structuring of data. Okay, so I cannot use the word rather data structure also. So it is misleading to some other thing. So nature of data will be the better way to say this. Am I dealing with numeric, or am I dealing with count, or am I dealing with categorical binary or polycotomous, so on and so forth. Okay, that will dictate you which tool you need to apply. With this input only, one can travel a coding language very, very comfortably, seamlessly, whatever the domain, whether you are in a medical or you are in a psychological, etc., etc. As well, what your role, you are in academic or you are in industry or you are in a student, you do a project, etc., etc. Nothing will stop if we make sure that these areas are completely described before we get into that. Because even if you start with matplotlib, I must know what variable I am trying to do for scatter, for box plot, for bar plot, for pie chart, for violin plot, etc. So plots are day by day it is increasing in the size. Utility tools are giving you in such a way that you can do n number of reports, n number of types of reports. But basically it starts from this classification. So hope you are able to get that connected with me. I don't say you don't know. So this is the way it goes. We'll go to the code part. I think I am into my timing. So I'm running my Python in Jupyter shared in this Colab notebook. Okay. So Colab notebook is a tool from Google so that I can share the code or output to anyone easily. rather than our locally developed, Jupyter. It is typically a Jupyter notebook. Therefore, those who are familiar with that, you don't need anything. But if you are new to this environment, you can try Collab from Google with your Gmail ID and your Drive. I'm loading it from my Drive, you would have seen. So it is quite comfortable. Typically a Jupyter notebook. Only one drawback which I feel sometime, or the users in the discussion forum also feel, is some packages or some libraries are not supported. If it is not, yes, we have to wait, because even if it is from Google, sometime it has to be developed, okay, for new tools, especially for certain modeling packages. Google Colab is not supporting. Not only model, even in a descriptive part, like one tool I remember recently, I have the trouble called BambooLib. BambooLib is a very nice tool you can explore um, for data summarization. Excellent tool, but unfortunately it is not supported in Colab so far. Probably, I believe, till now, but they may. It is an excellent tool for non coder. If anybody here, we don't like coding much, or if you want to get the code what you are trying to do, I may suggest a tool with this kind of background. BambooLib. You can Google it, and it is very easy to use if you are using it in a Jupyter notebook from your host local. Yeah, this is just an addition, nothing to do with what we are trying to do. So what I'm trying to say is, these are all various ways in which we can understand our tool set available. So I can load my data. Okay. And these are all, and while we do such things, naturally we have some restriction that I'm assuming that you are familiar with the syntax of Python, because we cannot divert ourselves to learn something like this. This is a routine way. That's why the code is available, because it is planned for some other classes. So the basic task of data science, like understanding our data set, is involved. So if you don't want, you can. I will run certain else. Okay, so this is the data type. As I told you, that we have integer for ID, because it is an ID of the data, but it is denoted by 1, 2, 3, 4. So Python reads as an integer, but you know it is not an integer. Similarly, maternity age, it is basically a numeric, so integer, or it is a float point. So here it is whole number, so it assumes as an integer. Then HT, hypertension, yes or no, so object. Gestation week, float. Sex, it is a male or female, therefore object. Birth weight, obviously it is again a float value. And the age group, then gestation category, they are basically coded, but it says it is an integer. So I need some pre-processing of the data. I'm changing the type to ID as object, so that it won't be manipulated for numerical calculation, even though it is a number that you have observed here in the head. If I run, you can find out that the output is ID is a number. It's ID. So nothing to do with that. It's just a data ID. Similarly, these two are seems to be numeric, but they are not. They are age group categorized, and gestation is categorized. This weeks is categorized into two level, less than 35 weeks and more than 35 weeks. And this is for age group, mother age group. Sex means the child gender, male or female. Okay, and the birth weight. So this is a simple data set I would like to show you, so that I'm using a pre-processing, very minute level, not very deep. So I'm changing the type essentially for ID and age group, then category. Then again I'm getting the output of this. So object. So comparatively, earlier it was integer, now it becomes object. Needless to say, because we are enforcing it in the pre-processing step. Now we are ready to go for scikit-learn. So scikit-learn requirement we need to take from regression part and logistic part. I fear whether these nodes actually have logistic regression part also, and more from variation inflation factor, something on the modeling aspect. I don't think I can connect all those things today, but this is prepared for that purpose. Okay, yeah. So we may try to do only this part mostly within the available time. So sklearn, that is the thing I am trying to load here, sklearn linear model. And I take the metrics for that other things. All these things are essentially imported. But if you are a beginner in the modeling, if you don't understand or if you are not yet to catch the after tasking of or post task of model building, you have to understand what is inflation factor, outlier, etc., etc. So that I leave to the audience. Whoever know already, yes, you can go ahead. Otherwise, first you build your strength on those aspects, what we mean by outlier, inflation factor, etc. Then you can make use of this code if at all you are interested in sharing from me. But today it is not a matter. I need not share. It is available anywhere. Okay. So it may be in a different manner, but we need to know how to connect. That's what I'd say. Keywords are important to learn. Then we can Google it, no problem. Then we can find out the right blog, right material. That is not an issue. So copying from a blog is not a problem. From a material is not a problem. But what to do? Right way to copy. That's more important. So it is not copy. We may say it's a reproduction of somebody's code. People are so generous that they share the code in GitHub. They share in their personal blog, in a community blog, wherever they want. Therefore, nothing wrong in it today. But what to do? Why should I need? These questions should be answered. That's what I focus on the first part. Right. Now, I try to do only linear regression because our birth weight is a numeric variable. Therefore, my response is numeric. So the code says I'm going to fit my linear regression with a predictor, only one predictor, which is also numeric, and response is also numeric. In all that aspect, this line fit one gives me the process of fitting. Fitting is ordinary least square estimation procedure. There are a lot of type. Minimum 10 types of regression is there. This is one kind of regression based on the algorithm called ordinary least square. So why it is, what is being squared and why it is least, what is the need for the term ordinary. Ordinary, I don't know, literally even today. Least square we know. So I leave it to you to go further on that. And the idea is it minimizes the square of error and the actual. So minimize the error. So difference between actual and predicted. That's the whole idea about linear regression with numeric data, numeric response. Okay. So if we run, we get this answer. I save the time because I have already that I am taking the intercept part and coefficient part. And the score is, if anybody is familiar with something called R square determination factor, so which gives a strength of variability explanation, then the model which a higher R square value is better. In this case, it is only 5.4 squared lower, but it is a value to compare. Okay, you cannot do with only one model. You have to run more model and try to come which has better. Better means closer to one. And with a word of caution on overfitting and underfitting and so on and so forth. We can explain more on that, but that is not the goal. So this is the code. I am taking the X variable because of the restriction on the data that it requires on a in an array. So I do this reshaping tools and all. Then I fit with this, and then I'm fitting the intercept. That means constant in my model and coefficient for the variable called gestation week. So we just now in the PPT we have seen gestation week and birth weight are connected. But what you have observed is intercept is minus 4,865. That means in the initial period of gestation, the birth weight of the baby is negative, which is not right. Therefore, I have to do an essential part of modeling called standardization of the tool, which I'm doing it through this in Skykit. Then you fit the model, which comes with the right answer. In the sense, right answer means not the optimum answer, meaningful answer or plausible way. So 3129 is the birth weight of the baby in the mid of gestation week, maybe 30 weeks or so. Say 5 into or 7, I mean 6 into 4, 24 weeks, 25 weeks and so. And then the number 481 gives that in each unit of increase in the gestation weeks, maybe a week, roughly 481 grams will increase in the weight of the baby. And that is the way we are trying to interpret. So that is how the interpretation works. And we can create more models with, I have so I'm not running anything, so it has those kind of, so you can use their RAM, and it is an interactive thing. So I don't say much on that collab, but anyway, don't surprise with that message. I'm not using, that means running execution anything, but for the initial ones. Okay, so likewise you can create more models and get the proper answers in a more better manner than this kind of lengthy answers. So I use one of the built-in function in Python, round to 2 decimal, and I try to do. So this is one way of getting that. Then obviously we will be involving some hypothesis testing in the linear regression model. For that I use this to get the p-value and other stuffs in fact. So for example, if I take you need to run. Okay, all these things. So p-value is date to 1. Okay, so this is the fit 6 in fact, and we have the data x d21, y d21. Okay, so this is p-value less than 0.05 so that you can use the respective conclusion. I don't go into the deep of why we calculate p-value, what is p-value, and so on and so forth. So that goes into some other direction. So scikit-learn is useful for completing a linear model, and there are many models available from this um, structured as well as unstructured models. Okay. Right. So finally, in the case of scikit-learn practice, if we have a data which we want to model. So first one is explanatory model, and here it is a predictive model where we need to get the training data, test data, training response, and testing response. You can use in such a way that you are able to split very simply using this function. This is one of the nicest function we have, and what proportion you want, 80-20. So I can run and get your size of the data from the whole set of data. I have 512 for training, 129 for testing, with 8 in my X test, and for Y test we have 129 as the response variable for the testing data, and this is the training data response variable. So this is one of the tools I would like to suggest you to understand first to build the prediction only model. So here we don't do anything on interpretation or p-value, etc., etc. Nothing to do. So there are two things I have shown you based on the input I gave in the beginning, that how you design your model. Is it going to be a prediction model or is it going to be inference model? So for both the things, we need a different approach. For first one, we don't need to split our data. We can use the entire data as such, same code. But when we use prediction model, obviously we need a data which is nothing but your training data and test data that will be available using your function in the Scikit package, train, test, split, whatever the way you want. So I have used a categorical data. So I use the hard code, one code pattern so that the data set is revised. That's what this part is doing. And then we try to complete that. So this short notice, I can let you to introduce the scikit-learn, which is primarily aiming to build models with the relevant input, relevant type of data, whether you are using a GLM, generalized linear model, polynomial regression, ridge regression, or elastic nets, neural net, whatever the topic you try to do, support vector mission, random forest, anything you can try with white box background or black box background. In the sense, inference based model or prediction only model. Whatever the way you decide, this package is allowing you to do in a more convenient, simple manner. So if you know the components of modeling, you can make use of the thing very, very comfortably. Okay. So all these things lie heavily on the first 15 minutes or 20 minutes I spent on the basics of your objective setting. If your objective is set properly, any tool is comfortable. Scikit-learn, yes, one among them. Okay. It has all the part to do. Basically, without these two, invariably no data science project is existing today in Python, because we need to treat data mostly in a structured data. We need a grid form, that means a spreadsheet form, and lot of data queries. So pandas is inevitable. Okay, so with that background, yes, of course, you can play in a seamless manner with tools like Scikit. Coming the second tool, Matplotlib. As I told you, the type of the data is important. So just now we observe the type of data, that gestation weeks is continuous, and the birth weight is also, and the continuous means numeric. Birth weight is also numeric, and we can have a scatter plot for both of them. So scatter is the term. So to save the time, I can use concurrently the Plotly also, because both are having a similar way of learning. So there is no big magic in it. So if you run both plots, you can understand the difference in the elegance, in the enhancement. My point of view for the people who are keen on visual medium, visual representation, I use three things: CAI, conceptual, aesthetics, and informative. You have to give the plot in a more conceptually writer's manner. Okay, very much conceptually writers, in the sense, for numeric data, what plot we need to do. For categorical data, what plot we have to do. Many users are making confusion between bar plot, box plot, or histogram many times. Okay, that is why I'm stressing that point on conceptualize. Second is aesthetics. What kind of color combination you are interested? It is not the question of personal interest and taste. The visibility, the readability, that color combination, how you are bringing out, these are all blocked in the theme what I devise as aesthetics. And third one is informative. So how better your graph is informative to the user, because you are going to give a static plot, let us say, then the plot will go to the user without the producer. So the plot has to speak on its own. Therefore, title, the label, the value, everything should be more and more self-explanatory for the plot. The picture has to speak to that audience. Otherwise, there is no use in it. In that way, the three themes, conceptual and aesthetics and information or informative, are my point of graphical tool uses. Whatever the graphical tool, it can be interactive, it can be touch screen, whatever the mode you are bringing out in an engineering legacy. But these three are very much important. Otherwise, the takeaway, storytelling is lost. Once the storytelling is lost, data science lost total requirement, total glamour as such. Storytelling is very essential. Therefore, reporting in any form is mandatory the to the analyst or the data scientist or whoever maybe it is. So there is a communication properly developed between the coder and the data scientist and to the presenter to the audience or to the business people. This is a tight teamwork. For that, you must be able to understand what is my requirement in the sense of these three. Therefore, this is developing based on basic to enhancement. Okay, so I am okay. I go to here. So here also you see I'm using deliberately I'm using the same data set because uh, you can compare quickly. Okay, only one I may show you, and other things histogram, box plot, and bar plot for the categorical data, then bar plot for the categorical data, box plot for numeric data, and histogram for numeric data. Purpose is same. Same thing we are doing it in Matplotlib also. But in the case of um, in the case of Plotly, we have some better enhancement, obviously. That is what the only thing I am going to show you with this available time. So this allows you to load the data in the given instant of Collab. Otherwise, it won't. Um, okay, so we have the load data now. I'll run this here as well as there. Okay, you see the difference. Yes, same scatter plot as I shown you in the PPT. You can connect to the problem. Here also I'm doing. Yes, this is the layout. Nothing more than that, enhancement. And you have to do a lot of things in fact, but here it is interactive. So when you are presenting in a screen in a live way, Plotly is inevitable. So it gives you a more on an interactive manner. Okay, this is you can hover, value, and add on more. So with the available time of next 3 minutes or so, I just vote myself for the Plotly quickly. But concept is same. I'm distinguishing it by color with a binary data 6. So the relation between gestation week and the birth weight is distinguished by the color. And higher again you can hover. This is one of the biggest change compared to uh, such plots, static plots. Matplotlib and Seaborn, there are many tools. They are all static plots. Plotly is finest on this area. That is how it is attractive, right? Enhancement point of view. Then histogram everywhere. I'm using birth weight because it's numeric data. And what it is going to give, that is the question. For example, if I say birth weight, box plot, unless you know why we need a box plot, it gives you, it when you go to Matplotlib, it won't give such a detail. For example, box, yes. Nothing you can read, but in Plotly you can read many details. Maximum, upper fence, Q3, what is Q3, what is median, what is Q1, lower fence, minimum. These details are quite important. It is not the question of something we plot and then show these details by different colors, different aesthetics, different labeling. Yes, all are in a click away, absolutely best. But the concern is, my concern is, what are you going to do to your user? That's more important. So this is, we need to learn in a very, very fundamentally and then try to use the tools. That is the bottom line. Always, ever I say to people that please focus on that. For example, upper fence. Upper fence is calculated from the interquartile range. What is interquartile range? Upper quartile minus lower quartile. So in what is the way it useful compared to maximum, in what way the upper fence is useful compared to median, what is the use of Q3? All these things are our responsibility. That means the analyst responsibility to speak about. That part is what I am more keen as to introduce or to describe, discuss a tool like this. So my focus is mainly on letting you, I don't say you don't know, but broadly speaking, okay, I make the point that communication or the storytelling, storyboard of a data analysis is the selling point for any project, which essentially starts from objective. And from the objective at one end, from the and other end at storytelling, in between, we have a lot of tools. One such toolbox is what we have seen today, Scikit-learn for modeling, whether it is an inference only model or predictive only model, or it is going to be my descriptive data for the major type of data called numeric data or count data or categorical data. I can make use of anything. So finally, I just stop myself with not much enhanced, but one of the tools available in the part of, okay, it takes some time. It is there, but my system is a 4 GB system, so you have to accept that memory and maybe without color. Okay. Yes. So a bar plot. So here I try to use on colors. I know some challenge in this kind of online presentation with my laptop, a limited resource one. Okay. Yeah, please bear with that. Nothing to do with that part anyway. So these plots are planned on Matplotlib. Somebody, I think in the message I could see that Skyborn is more attractive. Yes, that's what. It depends on the user way, what the user is planned to do. That will decide the tool to pick. But science, the data science cannot change your direction because it goes by theoretical rules. Numerical plot or categorical plot, yes, we have to take the family of bar or pie, maybe a variety, a cousin of pie chart. Yes, you can do. Enhance your pie chart. Yes, you can do. But you cannot make use of anything. Okay. So yes, somebody is talking about Seaborn again and again. I agree. I don't say that this is unique. I told this point already. I accept, and this is the way we have to learn many tools, compare them, which is essentially fitting to my need. If you are keen, then you are ready to go. Therefore, I don't say that Matplotlib is good or bad, nothing. We are trying to expose to something. That's it. Okay. So equally, somebody is interested in Seaborn. Yes, no doubt in it. They are comfortable, no problem. Somebody is comfortable with Plotly. Yes, let them do. It's the world gives you an open source tool like this optimistically and generously also. It is up to us to develop beautiful data analysis reports or tools or products using those tools. I know that time is up. So I thank all of you for your patient listening, but I am ready to stay if there is any question beyond this time frame. Otherwise, thank you once again for your patient listening and the opportunity provided and the time and the effort you invested for this session. Thank you all, but I am available for 1 or 2 minutes. In the sense, if you have question, I can extend my stay. Otherwise, yes. Thank you,
Good
sir.
evening, sir. Good evening, sir.
Yes.
You nicely emphasized on various analytical models and tools. I have a data like this gene pattern.
Okay.
Gene pattern. It is nothing but DNA sequence. It is a combination of four chemical bonds: AGTC, adenine, guanine, thymine, cytosine.
Okay.
It's a permutation and combination of a very lengthy sequence. If I want to compare a data of this kind with another sequence, what model I should use, sir? This is the data I have.
Yes.
Okay, we can call it as a gene pattern. I want to compare one normal gene pattern with abnormal. In what way, which model you suggest so that I can do a better analysis?
Yes. I don't presume anything from my side because I don't know anything from the basic knowledge, even though we heard about gene expression, which are all again very buzzwords today. Okay. Yeah. Therefore, to answer your question, my fundamental part is what I told you in the session. I think somebody is okay. So as I told you in the during the session, you please focus on the variable. If it is numerically designed, but gene expression, I don't know because it is restricted with some pattern.
Maybe gene expression, how we can visualize from any programming language, it is nothing but a string. It is a string.
Yes,
A
yes.
set of characters.
Yes. It is that's what I guess from my limited knowledge about gene expression. It may look like a pattern, right? A, like that.
Yeah,
Am I right?
AGTC, something
Yes,
like
something
that.
like that. Some numeric,
Yeah.
some non-numeric way of coding
Yeah.
it. Those
Yeah.
data invariably, if the categorization are limited, for example, 4 or 5 types of gene, 10 types of gene, something like that, these tools are quite comfortable to plot even in a simple bar chart.
Okay.
Then you can think about building a model with any regression type model if it is allowing you, because I don't know about the model aspect, like what are the predictors you have, explanatory variable you have. Without knowing that, I cannot make a overwhelming statement, but generally the model depends on the response variable's nature. If it is a multi-categorical data, whatever we have shown today as an example will not helpful to you. That we are very sure. We have to go for a neural network model or a better deep learning model for fitting it. Okay, because multi-categorical data is not that much easy to model. If it is too categorical, 3 or 4 multinomial neural models can handle it. Otherwise, it is not possible.
Okay, thank you, sir.
Yeah.
So, second question is, you said SkyKit. What exactly is SkyKit? Is it a API or a library? What do you say, sir? Is it a tool?
It is library. They are giving API also.
Okay.
They are giving API also. If you visit their page, Scikit-learn page, it has a nicely supporting community and the blog writing, updated blog, of course, and social media like Twitter page and etc. So you can follow them. They share their experience in the international conference and etc. So you can connect with them fundamentally.
Okay.
So you can find your own group there probably.
Okay.
So it's a nice package, in fact.
Okay. Okay. Thank you, sir. Thanks.
Yeah.
Thanks a lot.
Thank you. If anything more.
Thank you, sir. Participants, do you have any doubts? I guess that's it,
Okay.
sir.
Okay. So I thank SRM Ishwari, Department of AA and DS and management
Sir,
asset.
we'll
Thank you for the
finish the
opportunity.
session with a vote of thanks, sir.
Oh, okay, okay. Yeah, sorry.
Thank you for this wonderful session, sir. Participants, please make sure to fill the feedback form sent in this. And tomorrow's session is on Matplotlib by Rahul Garg, who is a data scientist at Infosys Technologies. And timing is from 8:30 p.m. to 9:30 p.m. Please make sure to attend the session. I would like to conclude the session with a vote of thanks. We are delighted to have Dr. N. Subbaiah sir with us today and giving us this informative session. We would also want to convey our thankfulness for accepting our invitation and providing support and knowledge on this. And we thank you very much for taking time out of your busy schedule and joining us, sir. I would also thank all the participants for taking advantage of the session. Thank you all. Have a great day.
Thank you. Good night.
Thank you, Subbaiah sir.
Yes.
Accepting your invitation, and today you delivered a very good lesson, sir, and a very good knowledge share session for us. Thank you, sir.
Thank you so much, sir, for the opportunity, of course. Thank you.
Thank you, sir. Thank you.
Yes, sir. Thank you, sir. Bye. Good night, all.
Thanks, sir.